so now we're going to look at more complex composite functions. Sorry, this is a functions video. And then inverse functions. Okay, it's going to be quite tricky, so put your positive pants on and we'll rock and roll. Okay, so I just wanted to start off with something that I should have put in the last video, but I forgot. If you have a function like this and you're substituting in 2, be careful because of BIDMAS. So that is 3 times 2 squared plus 4. Obviously, you've got to do the indices before the multiplication. So that is 2 squared first, which is 4. Then times it by 3, and then add the 4. So that is 16. Okay. Same with this one. Be careful with your negative. 3 times minus 1 squared plus 4. Minus 1 squared minus 1 times minus 1 is a plus positive 1. 3 times 1 plus 4, 7. Okay. And then obviously with this one, this is a composite like we did at the end of the last video. So you work inside out. F of 3, 3 times 3 squared plus 4. So that's 3 times 9 plus 4, which is 27 plus 4, 31. Then you've got to put that into F again. So 3 times 31 squared plus 4. Now I'm going to use my calculator for this. Don't want to be embarrassing. So 31 squared is 961. Times it by 3. 2,883, add 4, 2,887, okay? Just be careful of BIDMAS. Okay, right, now we are going to go on to composite functions whereby you have not been given a number. So, here's f, here's g, here's h, and you've been asked to work out fg of x. Now this is different because last time we had a number here, so we just did g of that number, then put the solution into f. But this time, it wants us to do it in terms of x. Okay, so what this is saying is, we're going to take our g of x, we're working inside out again, so we're taking our g of x, which is x squared minus 1. X squared minus 1 is acting as our x. So, is acting as our x. So we are going to put that into f. So wherever we see an x in f, we are instead going to write x squared minus 1. So we're taking g and we're putting it into f. So g is becoming our new x. Okay, we're calling that x. Wherever we see an x in f, we're going to write x squared minus 1. So we've got x, which is x squared minus 1, plus 5. And then you just tidy. So x squared minus 1 plus 5 is just x squared plus 4. That is fg of x. Okay, this time we're taking f, which is x plus 5, and we are putting it into g. So this is now what we are calling x. So wherever we see an x in g, we're instead writing x plus 5. So here we've got x squared. So we've got whatever our x is, which is x plus 5, that is all being squared. Then we are taking away 1. If that is all squared, that means it is being multiplied by itself. So it's x plus 5 minus 1, tidy. Expand the bracket. However you expand the bracket is fine by me, as long as you don't mess it up. So you get x squared plus 5x plus 5x plus 25. Still got the minus 1 on the end. So it's x squared plus 10x plus 24. This is hard to get your head round, so just work with me. Keep trying to go back and forth, make sure you're happy. So gh of x, so we're taking h and we're putting it into g. So h is 3x plus 4. That is our new x. So wherever we see an x in g, we're writing 3x plus 4. So g is x squared minus 1. So we've got 3x plus 4 squared minus 1. Okay, don't forget, like the last one, 3x plus 4 squared means 3x plus 4, 3x plus 4. And you can expand it however you like. Oh, crikey. 4 times 4 is 16. So you get 9x squared plus 24x plus 15. Okay, that is your answer. Right, hf of x. So we're taking f and we're putting it into h. So our f is x plus 5. So wherever we see an x in h, we are writing x plus 5. So our h is 3x plus 4. So we are doing 3 lots of whatever our x is. And our x is x plus 5. So 3 lots of x plus 5 plus 4. That's what we're doing. We're putting it into h. 3 times x plus 4. I wonder if that just went on. Hopefully you're still with me. Okay, so 3 lots of whatever our x is plus 4. Then expand the bracket. 3x plus 15 plus 4 is 3x plus 19. Okay, the last one which I plonked on here, but I ran out of room for, so I'll just do over here, was h of x. And our h of x was 3x plus 4. Okay, so we're taking h, which is that, and putting it into h. So wherever we see an x, we are instead writing 3x plus 4. So we've got 3 times, when we put it into h, this h, we've got 3 times whatever x is. So our x is 3x plus 4. So we've got 3 lots of 3x plus 4 plus 4. Then you just tidy. So that's 9x plus 12 when I expand the bracket. And so that's 9x plus 16. Okay, that's composite functions. They're quite hard. You might need to keep coming back and forth to that explanation. Okay. Right, we're now going to look at inverse functions. Now, inverse functions would be easier if we had done rearranging formulae. So I might set you off on rearranging formulae at some point soon so that we feel like this is a bit easier. Okay, anyway, here we are for now. Right, it will ask you to write an expression for f to the minus 1 of x. That means if it's got to the minus 1, it means the inverse. It's a bit like where you'd have seen it before, would be when you're reversing a sine or a cos. You do sine to the minus 1, cos to the minus 1, okay? That is the inverse of cos, the inverse of sine. Here we're doing the inverse of the function f, okay? You follow these steps, you'll get it right. So, what we're going to do is we're going to take f, which is 2x plus 1, but we're going to call it y to make it easier. So we're going to say y equals 2x plus 1. You're then going to rearrange it to get x equals, just like when you're solving an equation. So we're trying to make x equals something something. Okay, so we're going to reverse the plus 1 by taking away 1. So that gives us y take away 1 is 2x. If this is confusing you, I'll send you to a video on rearranging formulae. Okay, we want x on its own, so we divide by 2, divide by 2. So that tells us that x equals y minus 1 divided by 2. That's your first step. So you make it y equals, then rearrange to make x equals, then you swap your x and y over. Okay, so we're going to swap x and y. Wherever we saw an x, we're going to write y and vice versa. And then it wasn't called y in the first place. We wanted to find f to the minus 1 of x, so we just call that f to the minus 1 of x. So f to the minus 1 of x is x minus 1 over 2. Okay, so your last step is to call it f to the minus 1 of x. It has to be a function with x in, okay? It shouldn't have y's anywhere in there. Okay? Right, same with g. So we're going to take the function g, which is x squared minus 1, call it y. Rearrange it to make it x equals, so plus 1, plus 1. How do you get x on its own if it's being squared? You square root it. So square root both sides. You've got the square root of y plus 1 equals x. Swap your x's and y's over. And then call it g to the minus 1 of x. Sorry. G to the minus 1 of x is the square root of x plus 1. Okay? If it asks you to do g to the minus 1 of 15, you would follow this process, find out what g to the minus 1 of x is, and then shove 15 in. So we have 15 plus 1, the square root of it. The square root of 16 is 4. Okay? You'd have to go through the whole process of getting g to the minus 1 of x first, and then sub in your number. Okay. Right, the last one, h of x. We gave you up here, h of x was x plus 5 over 4. Okay, so we're going to call that y. So y equals x plus 5 over 4. We're going to rearrange it to make it x equals. So it's being divided by 4, so we times by 4. opposite of adding 5, take away 5. So we get x equals 4y, take away 5. Swap your x's and y's over. Replace this with h to the minus 1. Oh, I just answered the question I talked about earlier. So h to the minus 1 of x is 4x minus 5. It then asks us, my laptop's dying, it then asks us to do h to the minus 1 of 6. So h to the minus 1 of 6 is now going to be 4 times 6, take away 5, is 19. That is our answer. We have to do all of h to the minus 1 first, then substitute in the 6.